RBCs. One of the questions says, what about the chances of getting normal versus sickle cell red blood cells? And so when we're looking at that, we know that sickle cell, if you have heterozygote AS, that under low blood oxygen, over an extended period of time, they produce, their cells become sickle. So these two parents are heterozygote. This parent is so 1/4 of, randomly 1/4 will be homozygous dominant, so they don't have the trait at all, and 1/4 will be homozygous recessive. So one of the questions they ask is, what are the chances that these parents will have 3 children who are homozygous for normal red blood cells? Well, it would be 1/4 times 1/4 times 1/4. So everybody see that? 1/64. Is everybody okay with that? All right, so why is it times and not added? Because what are the odds of having 3 children in a row? So 1 and, so if you use the word and, you're multiplying in the case of probability. If you're using the word or, then you're adding, right? So if the word or is used, then you're adding the probabilities. If you use the word and, you're multiplying the probabilities. So a specific order of events you want to multiply. All right, thanks whoever this was. Just want to make sure everybody got it. Thank you for sharing.
So you said one is probability and 1. This one's 1 because there's only 1 square. This one is 3 because it would be equal, which will be these ones. And also you're looking at normal, which would be this one. This one was only 1 because, right, because you're looking at the normal.
If we sign
Alexander's absent. Barrett's absent.
They're at their little programs.
Where are they?
The SIS program. 1/64. So maybe
I can't do excuse, unfortunately. So the district gives us three choices: tardy, absent, or present. And the office can put field trip, but I can't put field trip. So just so you know, I can't, I only have present, tardy, or absent, unexcused absent. So if I mark someone absent today, please tell them to check with the office and have them change it to field trip. Billingsley's here, Bryant is here. Colbert, marking absent, Colbert. Coleman, Cooper, Covington. Wait, it's Covington? No, she's absent. No, there she is. You changed your hair. I didn't recognize you for a second in this dark light. Crawford, Crenshaw, Dent. Anyways, Fudge. Is Heaven here? Notice Trent's obviously not here. Why do I even bother? So there's a really good phrasing here because this is it can be tough. Come here. It says, what are the chances of these parents with all three? We'll have all three children who have both normal and mutant hemoglobin. So normal hemoglobin. Now we're talking about what? We're talking about the polypeptide. The polypeptide here. We're not talking about normal as in the human being. We're talking about the polypeptide. There's 4 polypeptides, 2 alpha and 2 beta. You don't have to know all that. Just so if you have the gene for one of the a normal gene, the 2 normal genes, if the gene is normal for hemoglobin chain, then you have a normal red blood cell under low and high oxygen conditions. That means 2 normal genes. So let's say, I don't know, let's say big S. If you have one normal gene and 1 mutant gene, what they mean is that one allele is different, the recessive version, then when oxygen is low oxygen gas concentration in the blood, when you have low blood oxygen concentration, then the cell sickles. All right? Does that make sense so far? So this is what? 1 mutant gene, hemoglobin or polypeptide, and 1 normal polypeptide. Normal and mutant. And then, of course, if you have two mutant genes, then low or high, you have sickle cell.
So when it's saying mutant genes, is it talking about 3 out of 4?
when they say mutant genes, they're going all the way back to the chromosomes. They're saying you have this chromosome, and this gene is mutant, and this gene is normal. All right, so that's what they're talking about. So let's reread the question. What are the chances that these parents will have 3 children who have both normal and mutant hemoglobin? What does that look like if they have a normal and mutant?
That's my question. So
No,
the
that's-
normals,
No,
they
look.
don't have the trait, right?
Not you're no. No, I know that's your question, but listen to what I'm saying. They're saying they have a normal hemoglobin molecule. That means the gene for the polypeptide is normal. Right? They also have a mutant hemoglobin, which means that the other gene they have is mutant. It is recessive. So when they ask you the question, I'm going to read it again. What are the chances that these parents will have 3 children who have normal and mutant hemoglobin? What does that look like?
That they have the trait for it.
So what is it? Homozygous? Is it heterozygous? The heterozygous. That's right. That they have the trait and they're heterozygous. So you're asking what's the probability of having 3 kids 3 times big S little s? What's the probability? When you have parents that are what? Heterozygous. Correct? So when you have, and you used A. Did they tell you to use A?
Yeah.
All right, so use A and S. And why did they use A and S instead of big S, little s? It makes sense.
Is it confusing to look at?
I don't know. I think A and S can be more confusing, but the reason that they want you to use A and S is because this is not dominant recessive, is it? Do you all see that this is not dominant and recessive? Do you see that that sickle cell is not truly a recessive? The disease is recessive, but do you see the difference or not?
Yes, because there's still traits.
Right, so there's still traits. So what kind of inheritance is it? It's not dominant recessive.
It's
Odd.
Codominance would be like ABO blood group, so you're not showing both. See, I can see where you're saying, because you have both sickle cell and non-sickle cell. Or it could be kind of incomplete dominance as well. I'm going to go with incomplete dominance. But you can read on. In incomplete dominance or codominance, yeah, it's easy to get them confused. That's why they do ABO blood group and this, because ABO blood group is codominant for sure. A and B are codominant, O is recessive.
Can you kind of explain 4C?
Yeah, I will. So, give me a second here. So then because of that, then you can see, I think, where they're coming from. Is that right? You see that you're going to get 50% chance of getting somebody with a mutant hemoglobin. Yeah? All right, 4C. Complete the hybrid Punnett score. Oh, it's good. They have you do dihybrid.
It's the blood and
All right, so complete the hybrid square. Determine the frequency of different phenotypes in the offspring. Consider blood type and normal versus mutant hemoglobin. So you got to do both blood type and mutant versus no.
Because if they're heterozygous for type A, so that would be big A, little A?
It could be
Or would it be AB? Would they combine with
2 parents who are heterozygous for type A blood. So if they have type A blood, what are they?
big A, little
No, there's no little a.
A? But they say heterozygous.
Yeah, I know. So think about it. It's tricky. This is good. It's a good discussion. So you have so let's talk about it. You have, this is no bigger, there is no bigger small here because there's no dominant recessive. This is definitely a codominant situation.
So it'd be A, B.
No, it won't be AB because it would be, what would you get if it is AB? What kind of blood type? AB blood type. So remember, let's go ahead and kind of what we wrote last time. If you have I big A, well, that's obviously,
Wouldn't that be homozygous? Not
A. Well, that's homozygous, that's correct. So that's not it. This is homozygous, you're correct. Are we good with that so far? All right, so and then if I had this, then I would have this, and that again is this. Everybody okay with that? That seems simple enough, right? That's the easy part. And if I had, on the other hand, if I had this, why do I put little I instead of big I? Why am I putting little I instead of big I? Because these are recessive. This is a note. Should make a note that O blood type is recessive. It's tricky. So of course that blood type is O. And of course this again is homozygous. So I know you understood all that, but I just want to review that because it's in understanding this, then we can apply it to how do we get A blood type and still be heterozygous. The only way to do that, because these two are codominant, the only way to get A blood type and be heterozygous is what? If it was B, what would you get? AB. If it was IAIB, these are all examples of heterozygotes.
You said that it can't be little a or little b.
There is no little a, so that's correct.
It'd be a little I.
There it is. There it is, that's it, yeah. So this blood type would be AB blood type because it's codominant. The only way to get A would be to have big A, but these are heterozygotes, so that can't be. But if you had little I-O, now you have a heterozygote that also has A blood type. Now, do you see how much they pack into one sentence? All that was that one sentence. You had to know everything before it to answer that question. Is that good, or do you need me to continue with this? All right. Is it time to go already? I'm posting this now.